right, 2.3, polynomial long division. Now, this is technically a topic that you should have seen in Math 95, but it may have been a while since you've seen it, so we're just going to take our time reviewing it. So polynomial long division is when you take one polynomial and you divide it by another. So here we have one polynomial, we're dividing it by the other one. The part that you're dividing it by, so I'm dividing a polynomial by x plus 3, we call him the divisor. And the polynomial that we're dividing, we call him the dividend. The way that this is set up, let me scroll because we'll need space. The way that this is set up is you put the divisor outside, and then the setup might look familiar. You put the dividend on the inside. I'm going to warn you that Alex teaches this a little bit different than I do, and you can use either method. I'm just going to teach you the method that I was taught and the method I think makes most sense. So your first step, you take the leading term on the inside here, right? So let me kind of underline him. You'll take that 6x squared, and you're going to divide him by the leading term of the divisor. So leading term of dividend by leading term of divisor. So here I have 6x squared divided by x. That gives me 6x. That's what you put up top here. So, boom. The next step is to multiply your divisor by whatever you got here, and then we're going to make everything an opposite sign. So my divisor is x plus 3, so I'm going to take 6x and multiply it by x plus 3. I get 6x squared plus 18x. Now, the way that Alex is going to write this, they're going to say do minus 6x squared plus 18x, and then remember to distribute the negative sign to both places, but I'll tell you that you're just not going to remember to do that. So in my professional opinion, let me do some erasing. In my professional opinion, since subtracting is just making things the opposite sign, I just make things the opposite sign when I put them underneath. So it was 6x squared plus 18x. I'm going to make it negative 6x squared minus 18x when I put it underneath. So negative 6x squared minus 18x. And then when I say add down, I really just mean whatever you see here, you just do that math. So this is 6 minus 6, so they cancel, which is by design, they should cancel. And then this is 25, positive 25, minus 18, which will give me 7x. And then you pull down whatever's left over. Oh, goodness. Don't know what happened there. You pull down whatever's left over. So then we move on to our next step, because we are not done. You're going to take your new leading term and divide it by the leading term of the divisor again. And we're going to repeat the process. Right? So I am going to try to scroll down real quick. Excellent. So I'm going to take 7x and divide it by x to get 7. Because it's a positive 7, I'm putting a plus sign. All right. Then I am multiplying, and it never takes this long. Once you actually start doing this process, it'll be very fast. It won't be this long. So I have 7x plus 21. So those are both positive, but when I put them underneath, I'm doing minus 7x minus 21. I'm making them both their opposite signs. The 7x's cancel, and I'm left with a 2. So you repeat this process until the degree of what you're left with is less than the degree of the divisor. So I'll make that note here. I'm running out of space. So 2 is degree 0, x plus 3 is degree 1. So now that this guy is smaller than this guy, I'm done. And let me get a red pen here. This guy up here we call the quotient. And this guy down here, whatever is left over, we call that the remainder. So our answer here, 6x plus 7. Sometimes people write this as remainder 2, so that's a common way of writing it. However, the way that you really should be writing it in calculus is the quotient plus the remainder over the divisor. So the way that I would write this guy, I would write it as 6x plus 7 plus 2 over x plus 3. Right. That skill is going to be important come calculus, so I would prefer you not write it like this. Alex is going to ask you to just give it the quotient and the remainder. It's not going to ask you to write it like this at all, but I'm going to continue writing it like this so that you see it multiple times. So let's go ahead and do some more examples. Right, so here we have another problem that I've already set up so that we don't spend time setting it up. I have my divisor on the outside, my dividend on the inside, and I'm going to start the process that I did before. So I'm taking this leading term and dividing it by the leading term of my divisor. So 12x cubed divided by 6x gives me 2x squared, which I then put on top here. And when I'm doing this process myself, I actually am not, if I'm doing it without teaching, I'm not actually writing this part down. So when I'm teaching it, I write this down, but sometimes when I do that, I forget to take this guy and put him over there. Hopefully I don't do it in this video, but sometimes I forget to do that until the end. I'm just going to throw it out there. All right, so then I have 2x squared, and I'm multiplying him by my divisor. So 2x squared times 6x minus 4 gives me 12x cubed minus 8x squared. When I go to put the result over here, I'm changing all of their signs. So instead of positive 12, it's going to be negative 12x cubed. Instead of a minus, it's going to be a plus. So plus 8x squared. The first terms cancel, then 16 plus 8 is going to be 24x squared, and bring down their other stuff that's still up in the dividend. Okay. Now we're looking at the new leading term and dividing him by still the leading term of the divisor. It's always the leading term of the divisor that you're dividing by. So 24x squared divided by 6x is going to give me 4x. And by the way, I know that I need to still keep going because this is a square and this is just a first power. This has to be a power that is less then the power of the divisor. So plus 4x goes up there. Then 4x times 6x minus 4 equals 24x squared minus 16x. Make them the opposite signs, so minus 24x squared plus, plus 16x. The first terms cancel. Negative 22 plus 16 is going to give me negative 6. Negative 6x. And then I bring down the minus 2. I need to keep going because this is raised to the power of 1 and this is raised to the power of 1. If they're the same power, you still keep going. This has to be less for us to stop. So my new leading term is negative 6x, dividing by 6x. I get negative 1. Negative 1 times 6x minus 4 gives me negative 6x plus 4. Then change the sign. So the leading term was negative. I make it positive. This term is positive, so I make him negative when I put it over here. Oops, I do red, negative 4. So the first terms cancel. Negative 2 minus 4 gives me negative 6. Now I'm good to stop. So my quotient is this guy up here. My remainder is down here. I'm going to write my answer in the way that I did on the previous problem. So the quotient, 2x squared plus 4x minus 1, plus the remainder over the divisor. So this guy right here, this is the quotient, negative 6 is the remainder. This part isn't, so to be very clear, this isn't the remainder. The 6x minus 4 part isn't the remainder. If I wanted to write out what each piece was, the quotient is the 2x squared plus 4x minus 1, and the remainder is just negative 6. It's just that when we write it like this. So we write it as the remainder over the divisor. So that's that for that problem. All right, let's look at this problem that's written in a little bit different fashion. If your division problem is written like this, the top part is the dividend and the bottom is the divisor. But something really important needs to happen here. 1, you need all power, so whatever your highest power of x is, you need to have all powers down to 0, even if there's not a spot for it. Even if I didn't have, let's say, an x cubed in here, even though my highest power is 4, I'm going to have to put an x cubed in there. So you need to have every power from highest to lowest included, and they need to be in descending order. So highest power to lowest power. So I'm going to rewrite this. My highest term is 4x to the 4th. There is no cubed term, so I'm going to put plus 0x cubed in here. Here's the reason for this. If I were taking 100, if I was just writing the number 1012, I could just say, oh, well, if this is a 0, then I don't need it, and I'll just erase it, and I'll just make this the number this, and that will still mean the same thing. It'll mean 1012. But you're actually missing a place. There's a place value there, right? We're putting a 0 there to denote there's nothing in the hundreds place. So we're putting this guy here to denote that there's nothing in the x cubed place. And then we have 6x squared. there is no, oh, there is an x term. There is an x term. It is plus 8x and then plus 11. So we're only missing the cubed term there. We're going to do the same thing on the bottom. So negative 4x squared, there's no x term, so I will put a placeholder in, and then minus 2. So my setup, negative 4x squared plus 0x minus 2 being divided into 4x to the 4th plus 0x cubed plus 6x squared plus 8x plus 11. I promise you that you will get very frustrated with these problems if you do not write it like this. First of all, it'll become near impossible, and second, it's just going to confuse you. You're going to confuse yourself, I can guarantee it. So make sure it's in descending order and make sure you have the placeholders. All right, so dividing the leading term of the dividend by the leading term of the divisor. So we have 4x to the 4th divided by negative 4x squared. This will give us negative x squared, which I will put on top. All right, and then I'm taking negative x squared and multiplying it by the divisor. I get 4x to the 4th minus 0x cubed plus 2x squared. Now, you could argue with me and say this could be a plus 0x cubed. It doesn't matter. It's a 0. Minus 0 and plus 0 are the same. I'm just sticking with that convention because if this is a negative sign and it multiplies by a positive, it would be a negative. Okay. And then I am flipping the signs on everything when I put it over here. So instead of positive 4x to the 4th, I'm putting negative 4x to the 4th. Instead of minus 0, which is irrelevant, I'm putting plus 0 x cubed. And then instead of positive 2x squared, I'm putting minus 2x squared. Now, this particular problem, if we had forgot to put the placeholder, it still would have turned out fine, but there's a lot of circumstances where it doesn't turn out fine, so just always remember the placeholder. So these cancel, these also cancel because they're just zeros. So 0, 0, they cancel. 6 minus 2, that's going to give you 4x squared. And then I will pull down the other two. So plus 8x plus 11. And let's grab the next color. So here's my new leading term. I'm going to take 4x squared and divide it by negative 4x squared to give me negative 1. So negative 1 up there. Negative 1 gets multiplied by the divisor, negative 4x squared plus 0x minus 2. So 4x squared minus 0x plus 2. And then we're using the opposite signs. So this would be a minus, this would be a plus, this would be a minus. 4x squared, 0x, and 2. The 4x squareds cancel. 8 plus 0 is 8x. 11 minus 2 is going to be 9. Now notice that the degree of my remainder at this point is smaller than the degree of my divisor. That's how I know it's time to stop. And if you tried to go another step further, you would have 8x divided by negative 4x squared, and you'd get something weird, right? This would give you like 1 over, sorry, not 1. This would give you like 2 over negative x, which doesn't make sense given what everything else has looked like. So you would know based on your dividing that something had gone wrong. So my answer here is negative x squared minus 1, and that comes from up here, plus the remainder, 8x plus 9, over the divisor, negative 4x squared minus 2. So when you go to write your final answer, you don't want to write your divisor with the placeholder. You just want to write your divisor the way that it looked in the original problem. But I'll make a note here, this whole thing is the remainder. Just trying to just finish that box. There we go. So that's that for that problem. All right, so let's go ahead and do one more example of long division, and then we'll move on from there. So first thing we're going to do is reorder and then put any placeholders in. So the highest power on the top is 4, so we'll start with negative 7x to the 4th. The next power is the third power. We also have a second power. I don't see any first powers of x, so I'll put a 0x in there, and then plus 10. And then the divisor is already written in descending order with all powers of x, so he's good. So we will set up our division. So negative 7x to the 7x to the 4th plus 5x cubed plus 20x squared plus 0x plus 10. Starting the same way we always do, taking that leading term and dividing it by the leading term of the divisor. We get 7x squared. And then we'll take 7x squared and multiply it by the divisor. Oops. So negative 7x squared times negative x squared is negative 7x to the 4th plus 7x cubed plus 21x squared. And then we will change all those signs when we bring them over. So this will be a positive, and then the other two will be negatives. Those first terms cancel. 5 minus 7 is negative 2x cubed. 20 minus 21 is negative x squared. And then I'm pulling down the other two. Right? So my new leading term gets divided by the leading term of the divisor. So negative 2x cubed divided by negative x squared gives me positive 2x, which I'll put up here. 2x times the divisor oops, that 2 looks really ugly. There, close enough. And then we are making the signs the opposite. So this would be a plus sign, this would be a minus sign, this will be a minus sign. 2x cubed, 2x squared, 6x. So the negative 2x cubes cancel. This is technically a negative 1x squared. So negative 1 minus 2 is negative 3. So negative 3x squared. 0 minus 6 is negative 6. And then the 10 comes down. We still keep going because these are the same degree. So you don't stop until the remainder is less. The degree of the remainder is less than the degree of the divisor, that is. So I take my negative 3x squared and divide by negative x squared to get positive 3. Positive 3 times the divisor gives me negative 3x squared plus 3x plus 9. Opposite signs when we bring it down, so that's a plus, that's a minus, that's a minus. The 3x squareds cancel. Negative 6x minus 3x is negative 9x. 10 minus 9 is 1. And now the degree of our remainder is less than the degree of our divisor, so we are good. And look at that, I forgot to put this 3 up here. I always forget to do that. Thought I was going to get through without doing that once, but nope. All right, so my answer here is 7x squared plus 2x plus 3. That's the quotient. And then we're writing it as the remainder, 9x plus 1, over the divisor, which is negative x squared plus x plus 3. So that's long division for you. So that was long division, but there's this other special type of, that's my dog. There's this other special type of division called synthetic division, which only works in certain scenarios, which you're going to see here. But it's so much quicker once you learn how to do it than long division. So in the scenarios where it can be used, which there are plenty of them, I would say it is preferred because it is much quicker. So it can only be used if your divisor is of the form x plus a number or x minus a number. So if there's a number in front of the x, like 2x plus 1, you can't use synthetic division. If you have like a square in your divisor, you can't use synthetic division. It has to be in one of these forms. So let's go ahead and look at doing an example. So you'll notice over on the side here, I've kind of done a short step-by-step process. I just kind of wanted to briefly put it there so that you could kind of see what's going on. It actually is a lot faster than this, and this isn't even finished. But the setup. So what you're going to do, if you'll notice over here, all of these numbers are the coefficients from the dividend. And this number over here is the opposite sign of whatever the divisor is. So if this is a plus 2, you put a negative 2 here. So for me, this is a plus 3, so I'm going to put a negative 3. So that's where that came from. And then I'm taking all of these coefficients, and they're already in descending order, and I'm just writing the coefficient. So I have a 4, a 10, a negative 14, a negative 22, and a 6. And then I like to draw a little line there because it helps identify where the remainder is. The remainder is eventually going to end up right in here. So that's step 1. That is my setup. Your next step, you're dropping the first number straight down. The first number in the first column drops straight down. So the 4 drops down. Then we're going to be multiplying diagonally and adding down. So if you'll notice here, I take negative 2 times 1 and I get negative 2, and then I add the 2 together to get negative 9. That's going to be what happens here. So I have 4 times negative 3. I'm going to put negative 12 here. (10) minus 12, so I'm adding straight down, is negative 2. So maybe off to the side here, I'll write the math that I've done. So I did negative 3 times 4 is equal to 12. And by 12, I clearly meant negative 12. Then I did 10 minus 12 is equal to negative 2. Now I'm taking negative 3 times negative 2 and putting it here. So negative 3 times negative 2 is positive 6. And then negative 14 plus 6 is negative 8. So that would be adding straight down. Negative 3 times negative 8 is positive 24. Negative 22 plus 24 is positive 2. So where was I on this? Let's see. Negative 22 plus 24 equals 2. And then we're just going to keep going. So 2 times negative 3 is -6, and 6 minus 6 is 0. So here's what we have going on. This guy right here, this is the remainder. These are the coefficients of our quotient. Our quotient is going to start 1 degree less than our dividend. So if our dividend was a degree 4, then our quotient should be a degree 3. So this is 4, that's my leading coefficient, 4, and then x cubed is my first term. So 4x cubed. And then I'm just going to start reading them off right down in a row. Minus 2x squared minus 8x plus 2. Since the remainder is 0, I'm just going to stop right there, and that is the synthetic division. So let's go ahead and look at another example here. This is going to really show you how much nicer synthetic division is. So first of all, I'm going to rewrite this so I have all the powers of x and make sure they're descending. So I have 2x to the 5th plus 0x to the 4th minus 6x cubed plus 0x squared minus 14x plus 0 all over x minus 2. Since this is x minus 2, the number that goes on the outside is positive 2. And then I'm just writing the coefficients in order. So 2, 0, -6, 0, -14, 0, and making myself a remainder column. So I'm going to show you how quickly this can go. Drop down the 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. -6 plus 8 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. -14 plus 8 is -6. And then 2 times -6 is -12. 0 minus 12 is -12. Our original started with a degree 5, so we'll be starting with degree 4 and using these coefficients. So we have 2x to the 4th plus 4x cubed plus 2x squared plus 4x minus 6 plus -12 over our divisor, which is x minus 2. You can just take it from me that this would take a really long time to do if you were doing long division. I mean, imagine all the work that we did for, this guy here only to have 3 terms in the quotient. This over here has, 5 terms in the quotient and then the remainder. So you're talking about a significant amount of effort, but it makes it a lot faster. So when you can use it, you should use it. All right, just a little bit left to talk about now. So let's talk about the factor theorem and the remainder theorem. So the factor theorem says that if you divide a polynomial by x minus c, and remember, this looks very familiar. This looks like the whole x minus the 0 thing that we saw earlier. So if you divide a polynomial by x minus c, also synthetic division allows you to divide by x minus c. If you divide a polynomial by x minus c and you get a remainder of 0, then you can say two things. You can say that x minus c is a factor of a polynomial and that c is a zero of the polynomial. So when you divide, if you get a remainder of 0, then you have found one of the factors of the polynomial. The second theorem, the remainder theorem, is if you divide a polynomial by x minus c, then the remainder is f of c. So what this is saying is if you wanted to find f of a number, that you could divide by x minus that number, and the remainder would be that value. But this one's a little less important, this one's a little more important. So let's get to using them. So this is a problem from Alex. It says, use the factor theorem to determine whether x minus 3 is a factor of p of x equals negative 2x to the fourth plus 4x cubed minus x plus 9. Specifically, evaluate p at the proper value and determine whether x minus 3 is a factor. So, let me get my color out there. If we wanted to find p of, and then if this is x minus c, that means that c is 3, right? If we wanted to find p of 3, we would just need to divide by x minus 3, and whatever the remainder is would be this value. Now, you of course could also just plug in 3 to this polynomial, and it would totally work, but I want to show you how fast and easy this can be. So if you're dividing by x minus 3, and we do synthetic division, this will go really fast. So I'm putting 3 on the outside, and I don't like the way that looks. There we go. Negative 2, 4. We are missing the second power, so we have a fourth power, third power, but we need a second power in there. So there's a 0, and then a negative 1 and a 9. Pull down the negative 2. Negative 2 times 3 is negative 6. 4 minus 6 is negative 2. Negative 2 times 3 is negative 6. 0 minus 6 is negative 6. Negative 6 times 3 is negative 18. Negative 1 minus 18 is negative 19. Negative 19 times 3, I'm not going to bother doing that in my head right now. Negative 57. And 9 minus 57 is going to give you negative 48. So when we did this, this number is actually the answer to this. So if you wanted to find p of 3, you could do synthetic division with 3 on the outside and just get that number, and that's what p of 3 is. It's that remainder. Now, in order for x minus 3 to be a factor, we needed this number to be 0. So we can say two things. We can say p of 3 is negative 48, and because it's not 0, x minus 3 is not a factor. So you're looking for this number to be 0 if it were to be a factor of this polynomial. All right, last problem. This is another one from Alex. For the polynomial below, 3 is a 0. And then we have the polynomial g of x equals x cubed minus 5x squared plus 4x plus 6. Express g of x as a product of linear factors. So previously, what we'd done, we had the dividend, and that's not spelled right, dividend over the divisor is equal to the quotient plus the remainder over the divisor. Now imagine if I came in here and I multiplied both sides by, let me write sideways here, the divisor. So if we multiplied both sides here by the divisor, so over here, the divisor cancels, and it would get distributed like that. So we'd have that the dividend is equal to the quotient, quotient times the divisor plus the remainder. because the divisors would cancel here and here. And this might not seem like a super important thing to mention, but it'll come in handy in a moment. So we are told that 3 is a 0. If 3 is a 0, by the factor theorem, that means that x minus 3 is a factor. So we're going to go ahead and divide this polynomial by x minus 3. Sorry, just skipped slides there. So we do the opposite of what we see here. So if it's a minus 3, then it's a positive 3 on the outside for synthetic, because I'm going to use synthetic. We have all powers of x accounted for. So we have 1, negative 5, 4, and 6. Pull down the 1. 3 times 1 is 3. Negative 5 plus 3 is negative 2. Negative 2 times 3 is negative 6. 4 minus 6 is negative 2. 3 times negative 2 is negative 6. 6 minus 6 is 0, which we were hoping for here because they told us that 3 was a 0, so it should work out. Now, this is the remainder. And we can get the quotient from this. So the quotient is starting 1 degree less than the dividend, x squared minus 2x minus 2. All right, so let me kind of scroll a bit. So we have a quotient, we have a remainder. This guy up here was our dividend. So let me use this formula to rewrite what we have. Because what we've been asked to do, we've been asked to factor the polynomial. So that's our goal, is to write it in its factored form. So, and in linear factors, that's important here. So it does say linear factors, which means that even if it doesn't factor nicely, we have to factor it all the way. So this is equal to the quotient, which is x squared minus 2x minus 2, times the divisor, which was x minus 3, plus the remainder, which is 0. Now, if I'm just adding 0 at the end, that's not really important, so I'm just going to erase it. So we are nearly all the way factored at this point. We just need to factor this guy. And don't have much more space on this page, but we're going to make it work. So this doesn't factor nicely. All right, I can just tell you it's not going to factor nicely, so we're going to use the quadratic formula. So we have x equals negative b, so this will be positive 2, plus or minus square root b squared minus 4ac all over 2a. A is 1. So we have 2 plus or minus the square root of, and then we have 4 minus negative 8, which is 4 plus 8, which is 12. So 12 divided by 2. This radical simplifies, so the square root of 12 is the same as the square root of 4 times 3, which is the same as the square root of 4 times the square root of 3, which is equal to 2 square root 3. So we have 2 plus or minus 2 square root 3 over 2, and we can cancel these 2's out since they all have a 2 in them. And we get 1 plus or minus the square root of 3. Those are the zeros of this guy here. They're not nice numbers, but they work. Just keep in mind the way that we write it in its factored form is going to be x minus the 0. And these are the remaining zeros. So we have x minus, and this is going to look gross, x minus 1 plus square root of 3, x minus 1 minus the square root of 3, and then x minus 3 at the end. because we have this x minus 3 here. And there it is factored. So the really important thing is it's always x minus the 0. So you're not changing these guys to be 1 minus and 1 plus. It's the inside part that's a minus and a plus, and that comes from the quadratic formula there. So once again, your steps here, do synthetic division. You're going to get a remainder of 0. You'll be left with a quadratic, and then if it doesn't factor nicely, you just use the quadratic formula to find the zeros, and then you write it as the 3 linear vectors. So x minus the 0, x minus the 0, x minus 3. And that's all there is to it. So that's it for this section. If you have questions, let me know. Otherwise, have a fantastic day, and I'll see you in another video. Bye-bye.